our models today, we're going to look at problems that have one type of quantity, but they're asking us for an answer in another one. So let's look at what this looks like in practice and how we can use what we know to solve the problem. So for example, in this one, we have John, and he ran 1 1/4 laps in 2 minutes. However, if he maintains his speed, how many laps did John run per hour? So do you notice how they're telling us time in minutes, but they want our rate in time per hour? So I'm going to use math just to start us off. Let's start off with the way we would normally solve this. And we know we have laps. And this is where, again, I want to write minutes, but I know my answer is supposed to be in hours. So I'm going to defer to hours, and watch how I do this, Math Marbles. We know the laps, 1 1/4. And how can I express 2 minutes in the context of hours? What do you know about minutes and hours? Well, I know that it takes 60 minutes to have an hour, and we only have 2 of them. So we have 2 out of the 60 minutes we need to make an hour. So I've just expressed what we have as a fraction. So we're going to have some complex fractions here, obviously. And we want to know how many laps if he runs for 1 hour. So here we go. We're going to cross multiply as we've normally done. So on one side we have 1 1/4. And on the other side we have 2/60 times a number x. So let's give ourselves some room. 1 1/4 is equal to 2/60 times x. I'm going to change this into an improper fraction. And we still want the x by itself, so I'm going to divide by 2/60. Let me go back a second. If this was just 2/60 times a number, you would rewrite this 2/60 times a number equals 5/4. You would just rewrite this as 5/4 divided by 2/60. You would just do that. So we're going to do that same process. We're dividing by 2/60. It just looks spicy, but it's the same process. We know this will leave you with just 1x. And on the other side, we have 5/4 divided by 2/60. We'll just rewrite this. 5/4 divided by 2/60. That's all we've done. We've rewritten a complex fraction as a simple division problem, and we know how to do this. 5/4 times 60/2 multiplied by the reciprocal is equal to, let's go, 5 times 60 is 300, and 4 times 2 is 8. So that's the last part we have to solve. We've done so much great work. This is where we can pick up our calculators, and you're just going to do 300 divided by 8. And that will give you 37 5/10. So let's put this into context again. 37 5/10 what? Look at your list. Where is that x? Laps. So let's put this in a full sentence. There we go. Hit pause and jot this one down into your notes. We're going to do more problems like this where we convert units. So take a look at how we do it in the next problem. Alan's water bill says he uses 1,600 liters of water. The bill was $348. What is the cost per gallon? If you read it too quickly, you probably would miss that we have 1,600 liters, but they want the cost per gallon. So here's what we're going to do. We want to know the unit rate cost per gallon. We know how much water he has in liters. We know what his bill costs. And we know that 1 gallon is equal to 3 785 on our reference sheet. So watch what I'm going to do. I'm going to give you both options. Method 1, we're going to use math to set up the problem. And we're going to convert liters to gallons first. So we can just find the number of gallons. Once we have that, we can find the unit rate by just taking the cost and dividing it by gallons, the 348, and dividing it by whatever number of gallons we have. That is a perfectly sufficient method if you would like to use it. Here's the second one. we can use dimensional analysis. Now, this is a method that you'll usually use in 8th grade math or on your Algebra 1 Regents, and that requires 2 different rates. In this case, the one that we're given, which is 160 liters, cost for $348. And so we can use the cost in liters, and we can multiply this by the conversion rate, liters and gallons. But the order absolutely matters. This is why this is more tricky. So if this is something you would like to try, fantastic. If it's one that you don't feel as comfortable with, no worries. You can just use math and use method 1, but I'm going to show both so that you have some exposure. So hit pause so you can jot this down into your notes, and we'll jump into our model solving the problem. All right, I'm going to give myself a little bit of space and room, and we're going to start with the first method, just using math. And we're going to start with liters. We're going to convert liters to gallons to start off, and we know that 1 gallon is equal to 3.785 or 785 thousandths, and we want to know, let's see, we have 1600 liters. You want to know how many gallons this is, so we can cross multiply, and we get 1600 on one side is equal to 3 and 785 thousandths on the other, times x. 3 and 785 thousandths, x is equal to 1600ths. And I'm going to divide both sides by 3 and 785. And that will leave me with x is equal to, again, you're taking up your calculator, you're typing in 1600 divided by 3.785, and you get 422 and 721. So it's a pretty ugly number. And this is how many gallons you have. So that was the first part of my step. And then next, what we would do here is we want the cost per gallon. So I can just take my cost, $348, and divide it by our gallons. And that will give us, let's see, 348 divided by 422.721. It gives us 0 and 82. Well, it gives us a 3, but we're talking cents here, like cost. And that's only 82 cents. So there's our answer. The cost is 0.82 cents per gallon. Now, this was all method 1. I'm going to show you the second method using dimensional analysis. So let me make a little line here. And again, you do not have to use this right now in 7th grade. So here's dimensional analysis, and it uses 2 rates. The first rate we have is cost in liters. So I want to put in what we absolutely want on the side. I want cost and gallons. So I'm going to use the cost first because it's on top. I want that to be my numerator. 348 to 1,600 liters. And I'm going to multiply this by, well, what do I know about liters and gallons? Now look at where I'm putting liters and look at where I'm putting gallons. That's intentional, Math Marvels, because I want, when we multiply, for these to cancel out so that I'm only left with gallons and cost. That's the tricky part about this. That's the part where once you master it, this becomes super easy. So what do we know about liters and gallons? We know that 3 and 785 liters in 1 gallon. So now, when we multiply these are going to cancel, and you're going to multiply $348 times 3 and 785 thousandths, and then you're going to multiply 1600 times 1 gallons. So that's what you're going to do. So take out your calculators. You're going to do 348 times 3.785, and you're going to get 1,317 and 18 cents. So that's the money divided by 1,600 gallons. And when you do that, math marbles on your calculators, you still get 0.823. Same exact number, 82 cents per gallon. So this is just 2 ways of doing the same thing. Again, this is not something you have to do in 8th grade, but I did want you to have some exposure in case you wanted to try something more challenging and new. But hit pause so you can jot these down into your notes. If you find dimensional analysis completely confusing, then only write down method 1. If you feel like you want to challenge yourself and try dimensional analysis, you can jot down both into your notes. Hopefully this was really helpful. Get some practice in. This is a little trickier because you have 2 units. So please make sure as you're reading, you're checking to see your units and if they match. Does the time match? Does the capacity match? And that is all for now, Math Marbles. I will see you in the next lesson. Take care.